Welcome back, everyone. In this video, we're going to expand on this network and simulate what it would be like if it was going to be the packets were going to be leaving this network to go to their default gateway and then out to the internet someplace. Now, this default gateway is sometimes called the default router. You might have heard of that. And all of you who are at home watching this, there is a router that is there someplace, whether you know it or not. If you're a home user, you probably got your router from your ISP, Comcast, Verizon, Cox, someplace. And the information was programmed in for you ahead of time. So the DHCP server is picking up the information from that router. Nevertheless, there is a router between your home network and the ISP's computer's network, which is eventually, of course, connected to the internet. So I'm going to go to my devices and I'm going to pick a Cisco router here, place it here. Now, I do want to give you a little bit of a warning up front that I'm going to be programming some of these devices without, and I will explain what I'm doing, but they may not make sense, and that's okay, because when we get to routers, I will explain in a great deal of detail about how these things are programmed. But right now, I'm just illustrating the concept of a local area network, and in this case, one that has access to the internet. Let me go ahead and call this the default router. And if I were to look at this router, if I open it up, you can see that back of it has got a bunch of empty bays. These are places to put in network interface card. It does have some ports. It does have some Ethernet ports that you can connect to, but your ISP may require one of these connectors to be placed in here. You also currently notice that this router is up and running. So if I were to add a network interface card in here, it says you can't add it when the power is on. So I need to turn this off, add that, and then turn it back on. Now, a little word of advice here about how Cisco names their ports. You can see that I just added this little port right here, and there are several. There are two ports that I see, two serial ports that I see right here. Cisco names their ports based on the device itself being device 0. Then the bays, they start with number 0 from the right. So this is bay 0, bay 1, bay 2, bay 3. And then the interfaces, the network interface cards start from the bottom up. So this is network, the port 0, port 1. So if you want to address this one right here, this would be device 0, bay 0, port 0. So it would be serial 0, 0, 0. This one would be the same. Device is 0, port is 0, so it would be 0, 0, but this is the number 1. If I were to add one more, let me just add it here just for the sake of being different. Let's put it over here. I don't know why I would ever do that, but let's say that we've done this. And I want to address this port. Well, this device is 0. Bay is 0, 1, 2. So 0, 2, and this one is in the bottom, so 0. So this is 0, 2, 0, and this is 0, 2, 1. Now, one thing you might be wondering, what is this device being 0 itself? If you're dealing with blade servers where you can slide these things into a blade, you might have a stack of these that are connected. And then that kind of makes sense. The very bottom one would be device 0, and then you have 1, 2, 3, 4, 5, etc. Hopefully that makes sense. I am going to turn this off and get rid of that and just keep this one for the time being, and then click this right here. Now, if I wanted to connect my switch to the router, I would still pick a straight through cable. Let's say pick a gigabit Ethernet for this one and connect it to the gigabit Ethernet of this router. And then this router itself would in turn be connected someplace to the cloud at that point. You notice that unlike the switches where they turn green eventually, these things are red, and pressing this doesn't make any difference, because while switches have ports that are on by default as soon as you plug in the switch, in fact, Cisco switches don't even have on-off buttons. They just come on and you plug them in. Routers, on the other hand, their network interface cards are down by default and they must be turned on. by us. So this port where this is connected to, which was gigabit Ethernet, I believe it was gigabit Ethernet 10 or 01, so 01. So this port would be considered the default port, which gets you to the default gateway, which in this case is the router. Now, because these three computers are on network 200.110, this port must also be on the same network. So if I wanted to program this this port, I could. Now, I don't program it on the switch, I program it on the device. So if I bring up this router and take a look at its command line interface, I'm going to bypass these ways that it wants to help. And don't worry about what I'm doing here. I'm going into the router to program it. I type EN, which is short for enable, and then I'm going to type in configure from terminal, and I'm going to go to interface. I don't remember what that interface was. Let's open it up and or check this out again. This is connected to gigabit Ethernet 00. Now, fortunately, we don't have to type that whole thing. We can just type in interface gig 00 like that, and it switches it to the interface mode where I can type in the IP address of 200.1.1. Let's say 100 is my gateway address, and I have to punch in my mask, like that manually. As I mentioned, these devices are turned off by default, so I need to turn it back on. The way you shut down an interface in Cisco is to type the word shut. If you want to undo something, you say no with that command. So no, shut. And you notice that this comes on. And I could speed this one through now, and this becomes all green. If I were to open up one of these PCs and ping 200.1.100, it can see its gateway. Now the PC can get to this interface, but it hasn't been really set up to access the gateway if it's necessary. To do that, we would have to go to the IP configuration, and for the default gateway, we would type in 200.1.100. And of course, the router is responsible for getting the data from here out to somewhere else, and we don't have anything right now on our screen for the somewhere else. We will, trust me, we will. But for the time being, just imagine that this is connected to other devices, and once the packet from this comes in, it's not for the local network, but it's leaving the network, is going to be sent to its default gateway to this address, and then this will forward it out to wherever it needs to go at that point. So because, as you can see, this could be a headache to have to go through each computer and manually put in this information, and if something changes, you have to go to all the computers and change them. Suppose the default gateway change and you have 200 computers, so you have to go through 200 computers and manually change all that. We have a service which is called DHCP, which solves this problem for us. And I will quickly demonstrate that right here just for your benefit. I'm going to open up this router, and what I'm going to do is I am going to change the network address to something else, so it's not on this network because I want the DHCP. So I'll make it 199, which is fine. Of course, now there is no connectivity from these computers. If I were to try to ping 199, you can see that it doesn't get there, but it will soon enough. What I'm going to do is I'm going to change these machines to be set up for DHCP. So that's DHCP. This one's DHCP. And this one's DHCP. Now we don't have a DHCP server set up yet, but I'm about to do that very quickly. I'm going to type in IPDHCP, and I need to give this a name. You can put a question mark, and it tells you what else it expects. It expects an address, a pool address, if you will. So IPDHCP pool question mark, and it wants a pool name. I'm going to call this, let's say, US. Oh, better yet, let's call it Florida. And it's going to switch to DHCP configuration mode. You can type in a question mark, and here it is asking for the information that we want. First is my network that I want to handle. So I'm going to type in, this is for network 199.110 with this mask. The default router is going to be the router itself right here, which is number 100. And I could add a default DNS server, etc. But that's all I want to do for here. I do want to type in IPDHCP excluded address, and I'm going to exclude this router's address from that DHCP pool. Because if I don't, then potentially could give this address to one of those PCs and it would not work very well. So we have a DHCP server set up, and these machines send broadcasts to the DHCP server to hear back from it. So that being the case, let's take a look and see what this one's IP address is. I'm going to type in ipconfig. And you can see that it's shown 169.254 because when I moved it from static to dynamic, it gave itself what we call an automatic private IP address because it could not find the DHCP server. Eventually, it's going to find it. It will take another few minutes, but what we can do is we can speed this thing up by just typing a renew command, a /renew, and there it is. You can see it picked up a 199.112 address from this computer, from this router. If I switch to this one, apparently somebody's picked up one address. This is why I picked up two, just so you know. Let's see if it was this one. Well, this one's already picked up 3 by itself, so this one must have picked up 2. So if I type in ipconfig, yes, this is the one that picked up 1. So this is 1, that's 2, that's 3. You notice that they don't match the computer names because, of course, they don't. It's a machine. But now I have connectivity. I'm on PC 1, and if I wanted to go ahead and ping 199.113, which is PC2 here, it should be successful. And I can, of course, ping my gateway too, because the gateway is on the same network. If I ping 199.11100, that's going all the way to this one and coming back successfully. Well, I hope this video made sense and you were introduced to some concepts perhaps that you didn't know about. You will see these things repeated throughout these video series. Thank you for watching. If you're enjoying these, please share with loved ones, and I'll see you in the next video.